There are objects in the universe so bright that a single one can overwhelm the combined starlight of its entire galaxy. From billions of light years away, it may look like one tiny point, but hidden inside that point is one of nature's most powerful machines, a quasar. The name sounds like a mysterious kind of star. It is not. A quasar is the fiercely luminous center of a galaxy whose supermassive black hole is actively feeding. Astronomers call this an active galactic nucleus, or AGN. Quasars are the most powerful members of that family. At the center sits a black hole with millions, or even billions, of times the mass of our sun. The black hole itself produces no light. The brilliance comes from matter that has not yet crossed the event horizon. Gas, dust, and sometimes material torn from stars fall toward the center. The matter cannot usually drop straight in because it carries angular momentum. Instead, it spirals around the black hole, flattening into a rapidly rotating accretion disk. Different rings of the disk orbit at different speeds. Magnetic fields twist through the plasma. Turbulence and friction move angular momentum outward, allowing matter to creep inward. As gravitational energy is released, the gas becomes extraordinarily hot. Blaze. The inner disk can shine in ultraviolet light and X-rays, while cooler regions glow at visible and infrared wavelengths. This is the key to a quasar's power. Nuclear fusion in a star converts only a small fraction of its mass into energy. Accretion around a spinning black hole can be far more efficient. A surprisingly small region, sometimes comparable to the scale of the solar system, can release more light than a galaxy containing hundreds of billions of stars. And then there are the jets. In some quasars, magnetic fields near the rotating disk and black hole organize plasma into two narrow beams launched in opposite directions. Whoosh! The particles travel at nearly the speed of light. These jets do not come from inside the event horizon. They are created outside it, where spinning plasma and intense magnetic fields can redirect a fraction of the infalling material. Astronomers are still working out the exact details of jet formation. But we know that some jets extend far beyond their host galaxies, sometimes for millions of light years. When one points almost directly toward Earth, relativistic effects make the quasar appear even brighter and more variable. That special viewing angle produces an object called a blazar. Here is another strange fact. Most quasars we see are extremely far away. Their light began traveling when the universe was young. Looking at a quasar is therefore a form of time travel. We see the galaxy not as it is now, but as it was billions of years ago, during an era when galaxies contained abundant gas and their central black holes were growing quickly. Quasars can act like cosmic flashlights. Their light passes through enormous clouds of gas between distant galaxies and Earth. Each cloud absorbs a particular set of wavelengths, leaving fingerprints in the quasar spectrum. By reading those lines, astronomers can map otherwise invisible matter across the early universe. Gravity can even create copies of a quasar. Split. If a massive foreground galaxy lies along our line of sight, it bends the quasar's light. We may see 2, 4, or more images of the same object arranged around the foreground galaxy. Because each path has a different length, the copies can show the same quasar at slightly different moments in time. The word quasar comes from quasi-stellar radio source. Early observers saw star-like points that emitted powerful radio waves, yet their spectra did not fit ordinary stars. When astronomers finally understood the enormous redshifts of these objects, the implication was astonishing. They were not nearby stars at all, but incredibly distant galactic cores. Not every supermassive black hole is a quasar. A black hole needs fuel. When a surrounding supply of gas is exhausted or pushed away by winds and jets, the quasar can fade. The black hole remains, quiet but massive, waiting for another cloud, star, or galactic collision to feed it again. So a quasar is not the black hole itself. It is the radiant storm around a feeding supermassive black hole. A spinning disk, a hot corona, strong winds, magnetic fields, and sometimes jets crossing intergalactic space. One tiny point in the sky, powered by a darkness we cannot see,